Welcome to a journey across the cosmos, where stars are born, live out their dramatic lives, and eventually die in a blaze of glory, or, a quiet fade into oblivion. We'll dive into the fascinating life cycle of stars, those glowing giants in the sky, and uncover what latest research has revealed about their evolution. Stellar nurseries, the cradle of stars. Stars are born in stellar nurseries, also known as nebulae, massive clouds of gas and dust where gravity decides to throw a wild party. Imagine a space where gravity gets overly ambitious and starts pulling in gas and dust until clumps form. These clumps grow larger and denser until nuclear fusion kicks off, igniting the birth of a star. The Eagle Nebula, home to the famous pillars of creation, is one of the most iconic stellar nurseries in the universe. These pillars hide the birth of countless stars within their wispy columns. The James Webb Space Telescope has provided unprecedented views of these regions, revealing intricate details that even Hubble couldn't capture. In these nurseries, stars are nurtured like cosmic seedlings, eventually becoming the shining beacons we see scattered across the night sky. Main sequence stars, the calm before the storm. Once a baby star, or protostar, gathers enough mass, it enters the main sequence stage, where it spends the majority of its life in relative calm. This is the longest and most stable phase of a star's life cycle, lasting billions of years. Our Sun, for example, has been hanging out in this stage for about 4.6 billion years. Here, the star converts hydrogen into helium through nuclear fusion, producing light and heat. This process is incredibly efficient, allowing stars like our Sun to shine brightly for extended periods. During this time, stars are like cosmic powerhouses, sending out energy across space and supporting the conditions necessary for planets like Earth to thrive. Yet, even in this calm phase, stars are anything but boring. They continuously emit solar wind, interact with surrounding space, and of course, provide the warmth that makes life possible on planets. Red giants, the midlife crisis. When a star exhausts its hydrogen fuel, things start to heat up literally and metaphorically. With no more hydrogen to fuse in its core, the star's core begins to contract under gravity, while the outer layers expand dramatically. This is the stellar equivalent of a midlife crisis, except instead of buying a flashy car, the star becomes a massive red giant. In this phase, the star's size can expand to hundreds of times its original diameter, swallowing any nearby planets in the process. Our Sun will eventually become a red giant, expanding so much that it may consume Mercury, Venus, and possibly Earth. While this might sound terrifying, don't worry, it won't happen for another 5 billion years or so. For now, red giants serve as a dramatic reminder of the dynamic and ever-changing nature of stars. Helium flash, the explosive makeover. As the red giant phase progresses, the star's core becomes hot enough to fuse helium into carbon, triggering what astronomers call a helium flash. This sudden ignition of helium fusion happens in a matter of minutes, releasing an enormous amount of energy. The core contracts even further, while the outer layers of the star get blown away in this stellar makeover. Imagine an aging star suddenly deciding to reignite its inner fire, only to shed its outer layers in the process. The star's luminosity can increase dramatically during this time, shining brighter than ever before. But this burst of energy is short-lived, and the star soon enters a more subdued phase. This phase marks the beginning of the end for the star, as it transitions towards the final stages of its life. Planetary nebulae, the ghostly farewell. After the helium flash, the outer layers of the star are expelled into space, creating a beautiful and ethereal planetary nebula. Despite the name, planetary nebulae have nothing to do with planets. Instead, they are glowing shells of ionized gas that drift away from the dying star, illuminated by the intense radiation from the exposed core. These nebulae are often breathtakingly beautiful, resembling delicate cosmic sculptures. They represent the star's final farewell, a ghostly reminder of its once glorious existence. Planetary nebulae are short-lived on cosmic timescales, lasting only a few tens of thousands of years before dissipating into the interstellar medium, where the material may eventually contribute to the formation of new stars and planets. White dwarfs, the retired life. What's left after all that excitement? A white dwarf, a dense Earth-sized remnant of the star's core. These stellar retirees no longer undergo nuclear fusion and simply radiate away their remaining heat over billions of years. White dwarfs are incredibly dense. 1 teaspoon of white dwarf material would weigh as much as a pickup truck. Despite their small size, white dwarfs pack a punch, emitting a faint glow as they gradually cool down. Over time, they will fade into black dwarfs, although the universe isn't old enough for any black dwarfs to exist yet. For stars like our Sun, becoming a white dwarf is the final chapter in their long and storied life. These stellar relics remain in the cosmos, quietly cooling and awaiting their eventual dark fate. Supernova, the ultimate fireworks show. Now, if a star is massive enough, at least 8 times the mass of our Sun, it ends its life in a spectacular supernova explosion. Supernovae are among the most energetic events in the universe, releasing more energy in a few seconds than our Sun will produce in its entire 10 billion year lifespan. These explosions are so bright that they can outshine entire galaxies for a brief period. Supernovae are not just dramatic, they play a crucial role in enriching the universe with heavy elements like iron, gold, and uranium. These elements are scattered across space, seeding future generations of stars, planets, and even life itself. In essence, supernovae are the universe's way of recycling stellar material, ensuring that the cosmic cycle of birth, life, and death continues indefinitely. Neutron stars and black holes, the afterparty. After a supernova, what remains of the star can either be a neutron star or a black hole. Neutron stars are incredibly dense, so dense that a single sugar cube-sized amount of material would weigh as much as all of humanity. These stellar remnants are made almost entirely of neutrons and have intense gravitational and magnetic fields. If the original star was even more massive, it might collapse into a black hole, a region of space where gravity is so strong that not even light can escape. Black holes are the ultimate cosmic afterparty where the rules of physics get a little wonky. They are often surrounded by swirling disks of gas and dust, known as accretion disks, which can emit powerful X-rays as they spiral into the black hole. These extreme objects are a fitting end to the lives of the most massive stars in the universe. Black dwarfs, theoretical endgame. In theory, after a white dwarf cools down completely, it will become a black dwarf, a cold, dark remnant of a star. However, because the universe is still relatively young, about 13.8 billion years, no black dwarfs are thought to exist yet. It will take trillions of years for white dwarfs to cool to this point, so black dwarfs remain a theoretical concept for now. These dark, silent objects would be the ultimate end of a star's life, quietly existing in the void of space, invisible and undetectable. The idea of black dwarfs reminds us of the long, slow death that awaits even the most brilliant stars. It's a somber thought, but one that underscores the relentless passage of time in the universe. Star systems in 2024, new discoveries and surprises. Astronomers continue to make exciting new discoveries that are reshaping our understanding of star evolution. For example, the recent discovery of lithium-rich red giant stars has puzzled scientists, as these stars contain far more lithium than previously expected. This challenges our models of stellar evolution and suggests that there may be processes occurring within stars that we don't yet fully understand. Moreover, astronomers are learning more about the early stages of star formation and the role that stellar winds and magnetic fields play in shaping the evolution of star systems. As our technology improves, particularly with tools like the James Webb Space Telescope, we're uncovering more details about the life cycles of stars, from their birth in stellar nurseries to their final moments as black holes or neutron stars. And that wraps up our cosmic journey through the life and death of stars. If you enjoyed learning about the epic evolution of star systems, don't forget to smash that like button and subscribe for more fascinating space content. Share your thoughts in the comments below. What part of a star's life cycle intrigues you the most? Thanks for watching, and keep reaching for the stars.